And in this video, I want to take a quick second and explore an important nuance to a common GMAT probability rule, and specifically probability questions that include or involve the word or, right? So certainly in my course, I actually have a separate kind of mini lesson just on GMAT probability and combinatorics. We treat it in our full course, and I teach kind of the major rules that govern probability questions on the GMAT. So we don't have time to go into all of them here, but one rule I do want to talk about is this idea of kind of multiple iterations, or when you have multiple things happening. Sometimes we have the word or, and sometimes we have the word and mathematically, this is just a kind of a simplification of what's going on, but it's how I kind of like to think about it. When you see the word and, you multiply things together. Like if, what's the probability of getting a heads on 2 flips of a coin? Well, the probability of getting a heads on the first flip of a coin, and then the probability of getting a heads on the second flip of a coin, you take the probability for the first instance, and then multiply that by the individual probability of getting heads on the second instance, right? So you're multiplying things together. When we see the word or, we add things, right? So we think about or as adding things, we think about and as multiplying things. Again, kind of a generalization, but I want to take a closer look at kind of the or scenario here for a second, because there are 2 potential kind of ways of applying it, and sometimes on harder questions there will be an aspect of it that is important for you to at least be aware of. Now, when we have kind of the probability of something or something else happens, like I said, we add those things together. So, for example, what's the probability, go ahead and change pen colors here for example, what's the probability of rolling a die, one die, a 6-sided die, and you roll it, what's the probability of getting a 2 or a 3? Okay, pretty straightforward, right? So I can either get a 2 or a 3, both count. And kind of the formula is that it equals the probability of getting the 2 plus the probability of getting a 3. So we're just going to add those things together, right? And so it's very simple, very straightforward. The probability of getting a 2, it's 6 sides, there's only 1 2 on a die, and so the probability of that is 1 out of 6. But then we also have the opportunity of getting a 3, that would also count, so we add then the individual probability of getting a 3, and 1 6 plus 1 6 is 2 6 or 1/3, right? So that's the probability of getting a 2 or a 3, which by the way is a direct application of the basic kind of formula for probability, the basic rule of probability, which says it's the number of favorable outcomes over total outcomes. Well, here we have 2 favorable outcomes, so 2 favorable outcomes over 6 total outcomes. You kind of gotten that a lot faster. 2 out of 6 reduces to 1 out of 3. So that's kind of the background I want to give you, but now I want to talk about the nuance I was talking about, which is to say, in this scenario, it worked exactly like I talked about because there's no chance that you would get a 2 and a 3 at the same time. But technically, and this is kind of the formula that I want to give you, the nuance I want to give you. Now, most of the time on the GMAT, let me say you this is going to be what you do. Most of the time when you have an or scenario, you simply add the independent probabilities and you are done. But technically, the formula is really the probability of A or B, right? So in this case, a 2 or a 3, is the independent probability of A plus the independent probability of B minus the probability that you would get both of them together, right? The probability of A and B. We have to subtract out any overlap. We have to subtract out the possibility that we would get them at the same time because that's not what we're talking about. And let me give you an example to illustrate what I mean. Let's pretend we have a different scenario, and we have a question where a student, John, is going to be taking 2 subject tests, okay? And so John is going to take 2 subject tests, and on the first one, his chance of passing that test is 3/4, okay? So John has a 3/4 chance of passing the first test. He has a 2/3 chance of passing the second one. So he's going to take both. He's going to take the first one and the second one. And he's got a 3/4 chance of the first one, a 2/3 chance of passing the second one. Here's my question. What is the probability that he passes the first or the second exam? What's the probability he passes the first or the second exam? You can go ahead and press pause and try that on your own. I'm not going to give you multiple choice answers like you would probably have on test day, or like you would have on test day, but see if you can kind of work it out, figure out what that probability would be. Go ahead and press pause. All right, let's finish talking through it. And I'll start by asking, how is this any different than this? See, inherent in the question, right? The question is, John takes 2 tests. The probability of passing the first one is 3/4. The probability of passing the second is 2/3. What's the probability that John passes one of the tests or the other? And here's the wording that's not in the actual question. Like it probably won't be there on test day, but the extra wording is, but not both. And that's the nuance, and that's what I want to point out. That inherent in an or question on probability on the GMAT is this understanding that where we want the probability of one or the other, A or B, but not both. So in this question up here, the rolling of a die, we want to know the probability of getting a 2 or a 3, but not both, So we would subtract that out. But here's the thing, it's impossible to get a 2 and a 3 at the same time. You can't land on both at the same time. It's only going to land on one or the other, so we don't have to worry about that. And most of the time on the GMAT, by the way, that's the case. You don't really have to worry about this but not both scenario. But on harder questions, so if you're getting into the 600s, upper 600s, certainly 700 level probability questions, it may dip into this area where you need to understand that we would need to subtract out that overlap, because inherent is this understanding that I want to know his chance of passing the first or the second, but not both. And so to work this problem then, very simple, we would say, okay, his probability of passing the first or the second equals the probability of passing the first plus the probability of passing the second minus the probability of passing both I guess it wouldn't be at the same time, you have to take them kind of concurrently, but first and the second. And so we would subtract those out, right? So the probability of the first is 3/4 plus the probability of passing the second is 2/3. So that part is pretty straightforward. My guess is you got that far. Question is, did you then subtract out the probability of passing both? And passing both, notice we have an and. This kind of goes back to that kind of second part of the rule I talked about at the very beginning, which is when we have an and scenario, we multiply those. So this probability of passing the first and the second is actually these two independent probabilities multiplied together. 3/4 times 2/3. That would be the probability of him passing both, and so we want to subtract that out, right? And so we can do kind of the magic X. It's just a way that I add fractions. However you want to add fractions, 3 times 3 is, so 9 plus 8 over 4 times 3 is 12. So that is 17/12 minus 3 times 2 is 6/12, so minus 6/12 is 17 minus 6, 11 twelfths, right? So 11 twelfths. Hopefully you can still see that on the on the screen on the whiteboard, right? So and it's a very high probability, right? We would expect him to have a good chance of passing one or the other. He's already well over 50%. He's got a 2/3 chance just of that one, a 3/4 chance of just the first one. So if I'm giving him essentially 2 chances, either one, I don't care which one you pass. I just want to know the probability you're going to pass at least one of them, right? Or like one or the other. Well, very high chance, 11 out of 12. Right? So anyway, that's the nuance. I don't want to kind of beat a dead horse here, but hopefully you found this strategy empowering. I know a lot more certainly about all the other probability rules, lots of hard applications of probability, and then certainly combinatorics with permutations and combinations and things like that. In my mini course on probability and combinatorics, certainly we address it in our full quant course and our comprehensive GMAT Prep course. So I encourage you to check those out. We'd love to work with you, but hopefully you found this little nuance empowering. If you have any questions about this, post them below. Would love to hear from you in general. What did you learn here? What was kind of an aha? Did you find this helpful? Please leave your comments below. And with that, use this. Be on the lookout for this, especially on the harder questions, so that you can go out and dominate the GMAT.